Okay, so we're going to move to chapter 4, and chapters 1 through 3 were kind of like an introduction to MIS. We talked about, what is MIS. We talked about collaboration information system, which has experienced huge gains with information systems. We talked about using IS for competitive advantage. In this next part of the course, this next module of the course, we're going to focus on some of the technologies, if you will. And remember, we said we're going to talk about those 5 things throughout this course: hardware, software, data, procedures, and people. And chapter 4 is about hardware and software. It's about the computer side of that equation. And some of this, I'll apologize now, is probably a review for you. Okay? Some of it is probably something you've maybe seen. I don't know what the hell goes on in Computer Science 101 anymore, but it may have been something you've seen in Computer Science 101. So what we're going to focus on first is we're not going to understand the nuances, the very small nuances of computer hardware, but as a business professional, you may be in a position where you're deciding on what kind of equipment, what kind of computers to buy for your staff or to implement at a facility. So you need to understand how we measure performance and those kinds of things. So we're going to talk, first question here is, what do business professionals such as yourself need to know about computer hardware? So let's start at some of the basic things. The first one is the CPU. It's called the Central Processing Unit. Who makes CPUs? Like, give me some of the main manufacturers of CPUs. Like, you may even have a sticker on here that tells you who made your CPU. You do. Who's one of the main makers of CPUs? Mine? What's that? Well, Dell is what they call, they make a lot of hardware, you're right, but they take a lot of components and put them together, and they buy from a couple companies that produce CPUs, but they kind of put all these components together. Who makes the CPUs though? The chips, the brains, yes. IBM. Okay. Intel. Like, you guys have a little sticker on here that says Intel inside, okay, and it says like the Core i5. Intel is a big maker of that. Remember we talked about Gordon Moore? He was the CEO, Moore's Law. He was the CEO of Intel. I mean, they are the word when it comes to CPUs. Okay, they are the main company when it comes to CPUs. Who else? Does anyone else know any other manufacturers of CPUs? It's almost monopolistic, but there are some others. Yes.
Qualcomm.
What is it?
Qualcomm.
Okay. Where are they from? I don't know.
They usually help make apples.
Okay. Another one is AMD. Have you ever heard of AMD? No? AMD is another producer. They produce for a lot of like low-end, like Chromebooks and netbooks, those kind of things. But the CPU is the brain of the computer. It does the calculations. It has all those transistors on it that can do the calculations. It's like switching. Okay, we'll talk about that in a second. And when we hear the terms like dual processor and quad processor, what does that mean? What is dual processor, quad processor, and some like servers might have 16 processors in them. What's dual processor, quad processor? A lot of times the central processing unit, the brains and so on, the functions, a lot of faster computers, they may have 2 processors, CPUs in there working simultaneously, or 4. So it's like you having 2 brains or 4 brains. So a lot of times you hear like quad core, dual core. That means they have like 2 CPUs functioning at once. Now, CPUs vary in speed, function, and cost, right? The processing power, if you think about that's the software that's driving it. How do we measure CPU speed? What do we measure CPU speed? Yes, sir. Throw something out. I'll make it right.
With RAM.
Okay. Well, RAM is a good thing. When we hear RAM, okay, RAM refers to what? What's RAM an acronym for? Right? MIS is a bunch of acronyms. What's RAM an acronym for?
Something memory.
It is. It's random access memory. And a lot of times it's just called your memory, right? It's just called your memory in your computer. And it works kind of in hand in hand with the CPU. Okay, and let me explain that in a second. But what's some speeds for CPUs? Let's talk about that. What are speeds? Do you know what the speed of your CPU is, or what's a good speed to have? Or go ahead. 1.2 what? I'm looking for the word after 1.2. Squirrels per second? No. What is it? 1.2 what? That's right. Very good. Okay. a lot of times you hear it's gigahertz. It used to be megahertz, right? It used to be megahertz is how a hertz is a cycle, right? So a hertz is a cycle, right? A hertz is a cycle, meaning how often it can like do something, like one transaction, if you will, like add something or move something. And if we think about 1.2 gigahertz, well, it's important to understand, and we're going to talk about that in a second, what giga is, right? Because there's a big difference between giga and mega. What's giga, basically? All right, go ahead.
I thought it was like a million or billion.
Okay, yes, it's billion, right? So it's saying we can do 1.2 billion computations per second, right? Think about that. That's how fast that is. Now, a lot of computers today are like 1.5 gigahertz is it's kind of in 2014, that's kind of a slower computer, which, you know, a few years ago that was unheard of, right? That's Moore's law in action. Now, if you buy a real high-end computer, I think they have like 3 gigahertz. I'm not sure exactly what your Core i5 in your machine is, but I'm sure that's on the higher end of that, okay? So that's how fast it can do something, like the hertz. Hertz is a cycle. So CPU works in conjunction with main memory, which is what we call RAM, random access memory. And here's how it works, okay? Did you ever have a problem when you have too many things running on your computer and it locks up? It's like, what the hell's going on here? It just locks up. You get, sometimes they call it the blue screen of death. Well, what has happened there? Why does that happen? Go ahead.
Virus.
Well, it could be a virus, yeah, but sometimes it's not. It's just like you've overwhelmed your computer. What's happening is when you click on like Excel, for example, okay? Excel is stored, like the program itself is stored on your hard drive, right? It's installed on your computer. But for you to actually use Excel, it has to take it from your computer, from the hard drive, and load it in what's called like main memory. It's kind of like, if we use you as an analogy, it's what you're thinking about right now, right? That's the analogy. Like main memory is, hey, we want to put it in main memory because we want to use this, right? It was over here stored, dormant. We want to bring it into main memory. And Excel takes a lot of memory, right? Because there's a lot of stuff it's doing. If you're doing like video processing or gaming, right? Think about gaming. You guys, if you're playing high-end PC gaming, it takes a lot of memory. So memory is how much like a computer can be thinking about it once, if you will. Like how much it can have like going on at the same time. It works in concert with the CPU, which is saying, okay, let's do this, do that, but it's like what can be available at this point in time, okay? Not sure if that makes sense to you. But sometimes people say, well, my computer's sluggish, I'm going to update the RAM. You say, well, what does that have to do with anything because I'm not updating the processor? Well, if it's sluggish, that means things are swapping in and out of RAM, and that's taking time. So we want to store a whole lot in there at once, right? Because that's the goal. So CPU reads data instructions from memory and store results of computation in memory as well. So that is some hardware, but there's all kinds of hardware, okay? If we think about hardware, we think about capture, transmit, store, retrieve, manipulate, display. One of the fantastic things is what computers allow us to do is store things, right? Store things forever. You know, how many, I often, like if I get a note or something like that, I want it to be electronically because I lose notes. So I take a picture with my phone and now I know I have it. And storage is cheap as hell, right? So storage hardware is used to save data in programs. Common storage devices are things like hard drives, okay? Optical disc, flash drives, CDs, DVDs, thumb drives. All these things are examples of storage mediums. Now, all of these things, though, come down to storing ones and zeros. Okay, so we're going to talk about that in a second. 1 and 0 is anything in a computer, anything that's digital, if you will, is stored in binary. What is binary? Christina?
Binary coding, like that's ones and zeros, yeah.
It's ones and zeros. Very good. Everything in the computer world really comes down to ones and zeros. And a 1 and a 0 is like a switch. It's either on or it's off. It's binary. You either do it or you don't do it, right? And the early computers, if you ever remember, you don't remember, but if you ever saw pictures, they had what were called vacuum tubes. You ever hear of vacuum tubes? They look like big light bulbs. And they represented on or off, right? Ones or zeros, okay? But now we have, little segments. So if we think about how does a hard drive store ones and zeros? How's a hard drive store ones and zeros? That's all it is. It's ones and zeros. How's a hard drive store ones and zeros? What is a hard drive made of? How about how does your credit card on the back store ones and zeros? Okay. What it basically is, it comes down to a magnetic pulse, right? If there is, it says this area is this area. If there's a magnetic pulse here, it's a 1. If there's not a magnetic pulse there, it's a 0. How about optical discs, like CDs and DVDs and Blu-rays? You turn them over, you know, sometimes you ever turn them over and you see, like, if it's not written on, it's like very flat, but if it's written on, you can see like the grooves and stuff. How does that store ones and zeros? And can store lots of ones and zeros. How's that work? You ever rip apart a CD player or a DVD player? No? No one? If I said your life depends upon you explaining to me how a CD or DVD player, you couldn't do it, you'd die. You'd die? No one? Yeah?
Or I do know like the center is where like everything is held.
Okay.
Like when you turn it over. Like,
Yeah, okay, so basically, if you look at that CD, DVD player, or the CD, you see, like, he said the center is where things are held. And that's where it starts writing, in the center, because it's less wide, right? So we can spin it faster. But the way it works, okay, when we write to a CD or DVD, what do we call that action of writing to it? What do we call it? The verb, huh? Burn. We burn a CD or burn it. You've heard that, yes? Well, what's happening is there is, on the back of a CD, there are these channels, basically, and these channels have either a concave or a flat section, okay? So there's a little laser, okay, it's different depending on what device you're talking about, but they have a little laser, you may have seen that if you broke up a DVD, it's a little like, you know,
Looks like an eye.
yeah, it looks like an eye. And it's shining down this laser, and what happens if you shine a laser into like a concave surface is it diffuses that light. Like it doesn't bounce straight back. It goes like, you know, everywhere, right? But if you shine a laser down into a flat area, what happens to it? It bounces right back, okay? And if you read it bounces right back, that's a 1. If it doesn't bounce back, that's a 0. But think about that. You know, it takes a lot of 1s and 0s to make, you know, a DVD of, I don't know, The Matrix, right? It takes a lot of 1s and 0s because all those things are stored. So think about how fast that's working, right? How fast, like, that's working. The 1s and 0s are working. It's not like, all right, 1, 0. It's spinning, it's relations, 1, 0, 1, 0, and it's creating, you know, graphics or video or audio. All those things are digital, but they're all stored as 1s and 0s. Make sense? Yes? No? I like to think about it this way. And this is a good example, I think, because we've all seen this. In your high school gym, you have the score, and the score looks like this. You know, this is the scoreboard for the score. It might have, I don't know, these little light bulbs, right? I think it looks like this, something like that. You guys know what I'm talking about? And when your team is winning 6-0, how does that look? Well, these are all on, these are all on, these are all on, these are all on, right? So think about that. All it is on or off, right? But we're using them to store, to represent a 6, right? These are all like binary representations. If you have 8, all of them are on, right? If you have 1, just these are on. If you have 0, the ones around are 1, okay? That's how things are digitized. Think about a picture. How do they measure pictures? How do you measure how good your camera is on your phone? What do they call that? Pixels, right? Well, a pixel, what is a pixel? A pixel is just a little, very, very little dot. So if you have a 13 megapixel camera, that's 13 little dots, okay? 13 little dots. If you got real close to it, you'd see the little dots, but our human eye can't detect those. But those little dots are represented by colors, right? If it is, I don't know, 863, that means it's a light blue. If it's 812, it's a light cranberry. If it's 1, it's white. If it's 2, it's black. You know, that's what I mean. All those pixels come together to form that picture. The same thing with audio files and video files. They're all 1s and 0s that are stored a certain way. Okay, so the basic building block of storage and any kind of thinking of a computer is 1s and 0s, which is binary. So let's get started with that. I have a quote on the board here. I'd like someone to read that quote for me. I'm going to pick on someone. So, Katie, you have your
There are 10 kinds of people in the world, those that get binary and those that don't.
Okay. Hold on to that, okay? Remember what she said. Now, the way binary works is we're used to base 10, right? Like, you get to 10, and then it goes to, 100, then 1,000, and then, 10,000. We're used to base 10. But binary is zeros and ones. So, we first start with something called a byte. And a byte is made up of 8 bits, okay? So a bit with a small b, okay, small b, is a 1 or a 0 representation, all right? So let's talk about a byte, which is made up of 8 bits, okay? 8 places where there's a 1 or a 0. Does this make sense so far? So each of those places is represented by, this is 2 to the 0, this is 2 to the first power, 2 squared, 2 cubed, 2 to the 4th power, 2 to the 5th power, 2 to the 6th power, and 2 to the 7th power. So what's anything to the 0 power? What's anything to the 0 power? 1. What's 2 to the first power? 2. What's 2 to the 2nd power? 4. We could do 8. This is 16. This is 32. This is 64. This is 128. Okay. So if we turn on this bit, and this bit only, it represents 1, right? 2 to the 0 power is turned on, we represent 1. If we turn on both of these bits, well, this bit represents 2 to the 0, which is 1. This bit represents 2 to the first power, which is 2. So 2 plus 1 is 3. So what if I had this configuration? What if I turned on this and nothing else? What does that represent? 4, right? Because 4 is on, nothing else. And from this, I can go from 0 to 255. If they're all on, it adds up to 255. If they're all off, it adds to 0. So you've heard of like 8-bit processing or 16-bit processing or 32-bit. Some of your gaming consoles. What's the Xbox? What's the Xbox? Does it say? It does say, but I can't remember what it is. It might be 32-bit or something like that. That's talking about how many, like the width. But anyways, that's too much. So if I turn on all these bits, what does that represent? So it says 1, 1, 1, 1, but what does that represent? 8 plus 4 plus 2 plus 1, 15. If I turn these off, that's 8 plus 1 or 9, right? Okay? That's binary, okay? And it's not like anything you really have to know, but it's good to understand that all we're doing in computer world is we're turning on and off bits to represent, very complex things. So, for example, we might have something that interprets a 1 or all zeros as black. The pixel's black. All ones as the pixel is white. If it's a 9, maybe the pixel is red. If it's a 7, maybe the pixel is yellow. Okay, so think about that. From these ones and zeros, we can build very complex structures, like a picture of me, okay, or a video of me talking, or whatever it might be. Anything that's digital is based on this structure, these ones and zeros, okay? So this is one of my favorite geek t-shirts, right? I have one. I didn't want to wear it today, but I have one. So, because it's like an inside geek joke, right? So read this for me again, Katie, and Katie, be careful, because you're now going to be part of the inner circle of geekdom if you read it correctly.
There are 10 kinds of people. I don't.
Ooh, where it's starting.
Huh?
Where's the text? Where's the text? So it's gonna be.
Zero,
It's gonna be.
one,
At the 2-1 is gonna be
There are
1.
2 kinds of people in the world.
Or is it gonna be?
What is this in binary?
That's what I was asking.
The 2's on, the 1's not on, so what is that in binary code?
2.
So read this again for me, Katie.
There are 2 kinds of people.
Welcome.
Sorry.
You get it?
Get binary, those that don't.
Right? So yeah, it's good, right? I like that. Okay. So now hopefully you guys get binary now, right? You guys get binary. And it's the building block of everything in the computer world. It really is. It's amazing. Think about it. how humans, how as humans we've gone from this simple structure of it's either on or it's off to build these very complex things, right? Audio, video recordings, you know, and if you have a better way to store ones and zeros, you know, a smaller way, a more efficient way, a cheaper way, you'll be a rich person. Go ahead, Pablo.
Do you read them right or left?
Yeah, you always start, on this end, okay? You always start there. That's always the lowest power. That's always 2 to the 0 power. Then this will be 2 to the 1 power. This will be, and this is 8-bit technology, right? This is 8-bit. But a lot of times we have 16 bits and 32 bits. And then you go to, instead of going to 0 to 255, if you go to 16 bits, you're talking about going to very big numbers, right? Very big possibilities. And that's where we're at. Like if you look at early graphics, okay, they look nice, but if we only had 255 colors for these pixels, you know, you can't get all the nuances like the shadows. Now it's unbelievable, right? There's all these nuances of pictures, right? Nuances of things like that. So because of Moore's Law, we can store these things faster, we can process them faster. You know, I just saw on Woot today, you know, my favorite site, Woot today, they had a 64 gigabyte flash drive. Okay, so what that really means, 64 gigabyte, I should say gigabyte. By the way, bits is, if you, in computer world, a lowercase b means bits. An uppercase b means bytes. Okay, so it was a 64 gigabyte flash drive, so it's about this damn big, and it costs $19.99, $20.
Well,
Okay?
how many bits are in a byte again?
8 bits in a byte. Okay? So think about that. Someone already told me what giga is. What's giga?
Billion.
So that's, and it's not exactly, but let's say 64 billion bytes. And how many ones and zeros in a byte?
8.
So 8, so that gives me what, 480, 512 billion ones and zeros on that little flash drive. You know, possibilities of 512 billion ones and zeros, pulses, either it's on or it's off on that little damn flash drive. Think about that, isn't that amazing? But that's where we're at. When I was at the bank, this is, 20, 30 years, 20, 25 years ago, we shared, like I was a programmer, right? We shared a drive of 20 megabytes. Okay, we shared, like all the programmers shared a network drive that had 20 megabytes. And 20 megabytes means, what, 20 million bytes. We thought, oh, that's a lot of storage space. We'll never use that up. Hell, now you can buy for $20 64 gigabytes. And some of these external hard drives are terabytes. Okay, we'll talk about prefixes in a second. Go ahead, sir.
Is the highest bits 128? Is the highest you can go? Like in others, so there's 8 bits, or 8 little circles, or zeros, or 1 bit. So how many bits can you go up to? You know?
There's like 64-bit processing, which is be 64 ones and zeros.
Is there unlimited? Could it be 128, or could it be 2 times?
It's not unlimited. It's just it has to do with the architecture of the processing. Okay, and that's it's not at one point it was all 8-bit processing. Then it was 16-bit, and then 32, now 64, now 100. You know what I mean?
Mm-hmm.
I don't know exactly where it's at, but because this Moore's Law, because storage space becomes cheaper and cheaper. Remember that cost-performance ratio? It's unbelievable. Okay, you can buy. Let's talk about the prefixes right now. Okay. I'm going to go, so we talked about bits and bytes, light switches representing, ones and zeros, directions of magnetism, that's what a hard drive uses and flash drives use. Reflection or no reflection, that's what optical discs use, like DVD, CD, Blu-rays, all those good things. But it's important to understand these prefixes, okay? And the reason it's important to understand these prefixes is because if you're wrong not by 2 or 3. You're wrong by a power of 1,000, right? Because every one of these is 1,000 higher. So a kilobyte is 1,000 bytes. And you might say, we moved from, God bless you, we moved from kilobytes to megabytes, and you're thinking, okay, who cares? But that's a power of 1,000 up, right? That's crazy. So would you rather make, $60 or $60,000? There's a big difference, right? or 60,000 and 6 million. So there's a big difference. So we need to understand these prefixes. God bless you.
Sorry.
What we see is kilobyte is 1,000. That used to be the standard for a lot of things. Things were measured kilobytes. You don't even see kilobytes very much because that's like child's play, right? Kilobytes is nothing anymore. You don't even see megabytes anymore. That used to be the standard. Megabytes is nothing now, right? That's a million bytes. A megabyte is a million bytes. Typically, here's where we start. Gigabytes. We're talking about how many billion bytes does this computer hold? How many billion bytes does this computer storage hard drive store? Now, the level up from that is a terabyte. We started now as consumers, to see terabyte situations. You can buy external hard drives of a terabyte or more for around $50, okay, which is crazy amount of data. Okay, that's 1,000 billion bytes. Okay, 1,000 billion bytes. Even higher than that is petabytes. You know, that is a million billion bytes. Okay, petabyte. We talk about, like Google say they process 5 petabytes of data daily. Okay, 5 petabytes of data daily. And then exabyte, which we never really see that very often because that's a crazy amount. That's 1,000 petabytes. And an exabyte, they say if you take every word ever spoken by humans ever and digitize it, that'd be about 5 exabytes. Okay? If you took every word I ever said, you ever said, every caveman ever said, run it out, that's about 5 exabytes. So that's the kind of magnitude we're talking about here. Beyond that, there's things that are really more theoretical, like they're called yottabytes and zettabytes. You know, that's other prefixes. You can Wikipedia them if you're interested. But it's important to understand, especially, you know, I would say these 5. Okay, those 5 are really important because if you're wrong by a power of 1,000. And you don't want to sound silly, right? You don't want to sound stupid when you're specking out computers or talking about these things because you're not wrong by 2 or 3. You're wrong by a power of 1,000. Now, when we talk about storage, I'm going to come back to this. When we talk about storage, the one thing that's not on the slides, but I do want to talk about, is storage and memory can be volatile or non-volatile. Okay, this is an important differentiation. Volatile storage is storage that is gone when you shut off your machine. Okay? Volatile storage are things like the RAM, the random access memory, like what you're currently doing on a computer. When you shut off your machine and turn it on, you know, it's usually gone, right? Because that's volatile storage. It's like in memory, like temporarily. Non-volatile storage are things that are stored on hard drives. That even when you shut down, you know, like you think about it, you saved it, right? It's printed on the hard drive. It can be retrieved later. Volatile versus non-volatile storage. So if we want to retrieve something later, we better hope it's on non-volatile storage. All right, I got one. I've got like 3 minutes left. I'll tell you my best storage joke. It's a little sacrilegious. Sorry, Frank, I know we're Franciscans, but it's a little sacrilegious. Okay, this is Bill Gates dies. Okay, and Bill Gates has had a checkered past, right? He's a ruthless businessman, right? He's crushed people, but he's also had a lot of philanthropy, right? His foundations have done a lot of good in third world countries and saved, literally, his efforts have saved probably millions of lives, right? So Bill Gates dies, and he goes to heaven, and St. Peter is there at the gates, and they said, we don't know what to do with you, Bill Gates. The reason we don't know what to do with you is because we have these opposing things, right? You've done some great things and you've done some bad things. We don't know if you're going to go to heaven or you're going to go to hell. So Bill Gates always the entrepreneur, always looking for, the better thing. He said, all right, how about this? I need a new version of Windows 2020 or something like that. He said, how about we let, and this word is so sacrilegious, how about we let Jesus and the devil have a programming competition, and whoever comes up with the best Windows 2020 gets my soul. And they agree to it, okay? So Jesus and the devil here are the rules. They get 7 days, okay? And they're supposed to program this stuff. So they start programming, and Jesus and the devil you know, they're very powerful. So they're making this awesome operating system, right? That has all the bells and whistles, all these things, you know, all these, you think about it, it happens on your computer, right? Unbelievable. So they're both programming. It's a 7-day competition. It's about day 6, and God gets wind of this competition. And he's not happy, right? He says, you know, we can't be having these competitions for the souls of people. So he throws down like a lightning bolt, right, which God does, I guess. And it knocks out the power for both the devil and Jesus, right? So, you know, the next day comes and it's Judgment Day. And St. Peter goes to the devil. He said, okay, let's see your operating system, the devil and Bill Gates. Let's review it. Let's see what it has. And the devil said, you know, here's what it is. It's not bad, but it would have been a lot better, but I lost everything. You know, when God sent down that lightning bolt, and I had to restart from scratch. So it has some bells and whistles, but not where I wanted it to be. Well, he goes to Jesus, and Jesus' operating system is unbelievable, right? It has all the bells and whistles, and St. Peter is like, wow, that's fantastic. You're clearly the winner. And he says, how come you weren't affected by that lightning strike? And he says, and this is the sacrilegious part, he says, haven't you seen the signs? He said, what do you mean? What signs? He goes, they're everywhere. Haven't you seen the signs? He said, what? He said, Jesus saves. Long way to go, right? Long way to go. All right, I will see you on, what's today? Friday. All right, so let's see what we have. Oh, thank you.
I mean, I still should probably
So wait, let me see.
do one.
No, that's okay. So 64. What did you do on these? So we'll just give you that. All right, we'll assume that you would perform the same on the fourth one,
It's
right?
starting pretty hard.
Okay.
I have a request.
All right.
Can you sign this? Because it's an online class. But,
You don't like it?
I think what I wanted to do was, because right now I'm a management and marketing and management double major, and I think I want to drop management to my minor,
Okay.
so I wouldn't need that class.
How's that class going? You don't like it, or?
I'm just not a fan of online classes.
Okay.
And it's like, it's not like an online class, it's like a,
Hybrid kind of thing?
well, yeah.
It's
like-
synchronous.
Yeah, it's like at 11, everyone has to
Is
like,
yours?
no, everyone has to log on at 11, and it's like,
Yeah.
you have to like listen to it, it's, I don't know.
To Mr. Shrum.
Yeah. She's super nice, I just don't really,
Yeah, she's a very nice lady.
Yeah.
I don't know.
the class itself isn't,
Isn't your cup of tea?
yeah.
Okay.
Thank you.
All right, Kate.
Dr. Migo? Dr. Migo?